Hello, my name is John Barton and I will be teaching on the energy storage module. So wind, solar, tidal and wave power have variable power output on all timescales, from seconds to years. So far, these largely uncontrolled electricity generation technologies have formed only a minor part of large electricity systems. Going forward, they have a huge resource potential and can provide most of our electricity, but only if energy storage is used to balance out the peaks and troughs of electricity generation. In the past 20 years, lithium-ion batteries have become much cheaper and better, but they are still only really commercially viable for high-value applications such as portable electronic devices and electric vehicles, plus a few small standalone electricity systems. But much more needs to be done to enable renewable energy and energy storage to meet all electricity demand and for other energy uses such as heating buildings, heating water and industrial energy use. So how can we address or enhance these energy storage technologies? Well, there are many different forms of energy storage as described in the module. The hydrogen energy unit, that's mine, will tell you about the production, storage and use of hydrogen. And hydrogen is very versatile, being both a form of long-term electrical energy storage but also a fuel. In the electrochemical energy storage unit, you'll learn about many different forms of battery. In the mechanical and thermal energy storage units, you'll learn about simple and phase change heat storage, gravity systems and flywheels. Finally, the application unit describes how energy storage fits into electricity systems at all timescales. So, designing a good energy storage system requires some knowledge of the chemistry and physics of the energy storage devices. It also requires knowledge of the needs of the electricity system around it. So, how much power is needed and for how long? Hence, which energy storage technology or technologies are most suitable? Economics is also important. So, does the value of the energy storage to the system over its lifetime justify its investment? The learning objectives of this course, you'll be able to describe the characteristics of each energy storage technology, list the pros and cons of each, describe different varieties within each category, provide typical values for their performance parameters. You'll be able to perform calculations on their behaviour based on physical and chemical laws and simplifying assumptions. You'll be able to describe how energy storage can be used to support system balancing in power systems with high penetrations of renewable energy. And you'll be able to list some special considerations of each technology. For example, in hydrogen, the safety aspects. We have study notes that you can read at your own pace, and lecture notes lectures that you can attend in person, watch live or over the web, or watch the recordings later. We also have the presentation slides, tutorials and coursework for you to do. You will get the answers to the tutorials after the tutorial is presented in class. Finally, there are exam papers from previous years and references to background reading material to learn more about the subject. This module has a total value of 10 credits, requiring 100 hours of study. The coursework is worth 25% of the marks and the exam counts for the remaining 75%. It's a good idea to read the study notes before the lecture so that you begin to understand the subject and identify areas where you need to spend more time. People come to the MSc course from all backgrounds. Some of you will be very familiar with some aspects but completely new to others. Please also attempt the tutorial exercise before the tutorial class. You'll get more out of it that way. And of course, ask lots of questions. If you're unsure of something, chances are other people are unsure of the same thing. We also have guest lectures coming to the course to teach you more about the field, and I look forward to seeing you on the course.